Hello everyone, I am Sunanta from SNS College of Technology, Department of Mathematics. Here as the continuation of the lecture series in the topic testing of hypothesis small samples, we are going to see testing of single variance and equality of variance in this lecture video, which are otherwise known as F-test. Here is the small recall of the previous topic in which we have discussed about the statistical concepts for variable tests, that is nothing but variance, population, hypothesis testing procedures, p-value, and what is standard deviation, and what is null hypothesis, what is alternative hypothesis, what is single variance, significance level, and all. In significance level we have dealt type 1 and type 2 errors, etc. Here is the test for single variance and equality of variance empathy part. So why do we have to use this F test? So too much variability. What is variance actually? Variance is how much it is the average values varying from the mean value. That is what is the variance actually. How the first ones is varying from the second one is what we are going to see here. Next is the defined part. So here test for comparing two population variances. So here if they are population normals, then we can use this type. So F test with n1 minus 1, n2 minus 1 as degrees of freedom. So this is not a non-parametric test. So test for comparing two population variances. Next is a ideate part in which is the population is normal. If the population is normal, we will use this test. If the population is normal, then the population mean is known, then we go for a chi-square test with n degrees of freedom, and if it is not, then we go for n minus 1 degrees of freedom. If it is not, population is not normal, then we go for non-parametric tests. Here is the small activity. Which test is used to determine if two population variances are equal? So since we know the formula of F as S1 by S2, we can clearly say that the test F test is when conducting a F test for variances, a very small F statistics suggest. So this suggest variances are approximately equal. Next is the applications. So test for single variance and equality of variances. So here the formula is F equal to S1 square divided by S2 square. So here the purpose may be single or difference. If the purpose is single variance, then we go for chi-square is equal to n minus 1 into S2 square divided by sigma square. If it is equivalence of variance, we go for S1 square by S2 square. So here in this population variances and all, null hypothesis is framed in such a way that S1 square is equal to S2 square. Next, alternative hypothesis is framed in such a way that S1 square is not equal to S2 square, or S1 square is greater than S2 square, or S1 square is less than S2 square. Then level of significance will be fixed at 5% level. And next we go for the test statistic formula. Before that, we have to calculate the standard deviations of both the populations using the formula summation x1 minus x1 bar the whole square divided by n1 minus 1, and summation x2 minus x2 bar the whole square divided by n2 minus 1. So on calculating this, we get S1 and S2. After finding that S1 and S2, we have to determine whether which one is the greatest. If S1 is greatest, then we go for S1 by S2, the whole S1 by S1 square by S2 square formula. If S2 is the greatest, then we go for the formula S2 square divided by S1 square formula. Next is the mind map of this. So in this video, we have seen single population variance. Next, in single population variance, we have seen chi-square test. Chi-square, that is a mean is known, mean is unknown. In mean is unknown, we have seen about degrees of freedom and statistics, and even in mean is unknown, we have seen the degrees of freedom as n1 minus 1. Next is the assumptions. So we have to assume the distribution is normal distribution, then we have to go through the sampling methods. After that we have to see the null hypothesis statement, alternative hypothesis statement and all. Next, comparing two population variances. So when it comes for two population variances, the S1 square by S2 square. Next is decision methods. So based on the test statistics value and critical value, we will decide whether to accept or reject the null hypothesis. Then we have seen the applications of this. Here are the references for this topic. From NPTEL and QMath and all, we can see testing of hypothesis. Thank you.